Digital automation brought the world's business logic online in centralized systems that required brand trust from its customers. Smart contracts have ushered in a new generation in business logic automation that operates with cryptographic guarantees. However, due to inherent limitations in storage and compute of blockchains, business logic has only just begun to be written into smart contracts. Adoption requires familiar tools that allow enterprises and dApp developers to bridge blockchain technology with centrally controlled databases and complex business logic. Doing so requires space and time, processing both transactions and analytics in a single trustless environment, connecting data and business logic to and from major blockchains. We are partnering with the technology leaders of today's logic and tomorrow's automation to power the next wave of smart contract adoption in automating the business logic of the world.
Well, that room really cleared out. Let's get some people back in here. Let's wake up a bit. This is a journey through space and time, a story about smart contracts, where they've been, the current state, and where we see them going in the next wave, the next bull run, the next few years, and even deep state beyond that. I'm Scott Dykstra, co-founder of Space and Time, a decentralized data warehouse for Web3 that's going to open up a whole new set of capabilities for smart contracts to power the business logic of the enterprise, of the startups in Web3, and of the future. This requires a lot more compute than smart contracts have today. It requires a lot more access to data than smart contracts have today, and we're here to fix that. I spent the last decade at Teradata, a leader in centralized data warehousing, kind of centralizing the Fortune 500's data into the cloud. And it's funny to see blockchain completely erase all that hard work we did, and I love it. It's great to see blockchain saying, instead of taking the world's data and centralizing it into single points of controlled by large organization and cloud hypervisors, let's take all that data and let's spread it across a global distributed network of nodes owned and operated by the community. We've come a long ways in a short period of time with partnerships with Chainlink, Microsoft, NVIDIA on the compute infrastructure side, and then big partnerships with Avalanche, Polygon, and Miston Labs, our friends at Sweet Blockchain, on the smart contract enablement side of things. What are smart contracts, and why do they matter? Like, when I first learned about smart contracts years ago, I was just shocked. I had no idea that this was even possible. Smart contracts are sovereign pieces of code that execute no matter what. They cannot be controlled by an individual. They cannot be governed by an organization, by a government. They cannot be shut down and censored. They are sovereign agreements between participants that ensure that those agreements are executed in a way that is fair, uncompromised, and best of all, guaranteed, cryptographically guaranteed. And if you think about cryptographic guarantees, it's not trust in humans. If you sell your home and you put your home in escrow, you're trusting your bank, or hopefully not your real estate agent, to ensure that escrow goes through, and occasionally there's problems with your paperwork. On the blockchain, smart contracts ensure that these agreements are executed in a transparent way with cryptographic guarantees. They are going to power the business logic of the future. Without smart contracts, we can't mint NFTs. We can't power blockchain-based gaming. Without smart contracts, we have no decentralized exchanges. Hell, we don't even have centralized exchanges without smart contracts. Smart contracts ensure that agreements between two parties and the transfer of tokens and the minting of NFTs and the actual business logic that runs on the blockchain is governed by a global network of decentralized servers, operated and owned by the community. When you deploy a smart contract, you're deploying sovereign code. There's a problem, though. If smart contracts actually had the compute power that they needed, and they had the storage volumes that are required to power these enterprise use cases, then we wouldn't have $70 gas fees or even $20 gas fees, right? Smart contracts, surprisingly, especially on the EVM chains today, don't really have access to a lot of data. Something as simple as, show me all wallets that have purchased 2 NFTs. If you want to write business logic that simple, hey, give me all the wallets that have purchased these 2 NFTs within my collection, and I'm going to give them an extra incentive on chain or an extra reward on chain. Business logic that simple cannot be done today on an EVM-based smart contract. It kind of feels like a 1980s COBOL mainframe, right? It's got enough power to power like a bank, to power Wells Fargo, but it certainly doesn't have enough compute power to enable a mature social network. or enable, for example, an entire industry, oil, energy, transportation, banking, right? But right now, things are a little black and white on chain. Unfortunately, most of the people building in Web3 are either building mostly off-chain or completely on-chain with limited resources, building on these limited smart contracts, building with limited business logic. Developers that are building big blockchain games, social networks, they're all building off-chain in the same Web 2 databases that powered the last decade, and they're connecting little aspects of that infrastructure to their smart contracts. Alternatively, there's folks that are building fully decentralized. There's the Uniswaps of the world, the decentralized exchanges of the world that are fully on-chain, but it takes years just to even upgrade their smart contract, just to add more compute power, just to even add more business logic. Space and time's a conduit that attaches to smart contracts on major chains like Ethereum, Avalanche, Blockchain, Polygon, or Binance, Polygon, et cetera, and enables additional compute, additional business logic that can usher in this next era of where we know smart contracts are going. We're all here because we all believe that smart contracts are the business logic of the future. But right now, what's on chain is NFT exchanges, automated market-making liquidity pools. What's on chain right now is a little bit of NFT-gated gaming. We've got to fix that. If we want true utility on the blockchain, we need to empower smart contracts. Space and Time does that by first indexing data from major chains, organizing that data and making it cryptographically guaranteed, and preparing that data for business logic and for smart contracts to access that data. And then Space and Time, of course, connects that data to smart contracts with Proof of SQL, a novel cryptographic protocol that enables all of these petabytes of data off-chain to be connected on-chain and business logic to be built on top of it. So indexed blockchain data is the first and most important thing. There's so many players in this space doing a great job of indexing data from the major chains, but that indexed data needs to be cryptographically guaranteed, tamper-proof. We need tamper-proof indexed data from Ethereum, Polygon, Avalanche, Binance, Solana, you name it, as well as off-chain data ingested in a cryptographically guaranteed way and prepared for smart contracts. This will power compliance and reporting, gross, SEC, gaming, DeFi, lending, institutional trading, of course, and then our favorite, NFTs. Now, before we move back to smart contracts, back to the fun stuff, let's talk about the compute power and the processing power needed to enable what we already see today in cloud hypervisors. The Fortune 500 runs in the cloud. I mean, like I said, I spent the last decade enabling that, and I love to tear it down. So here's how we tear that down. A truly decentralized data warehouse that's a hybrid transactional and analytic platform. It's got the transactional processing power to store to handle all these transactions fast enough to power dApps, fast enough to power data warehouses, fast enough to power gaming, but scalable enough to do real analytics. The snowflake of Web3, scalable enough to ask those tough questions that join 10 tables together with 10 terabytes for each table. Bringing this kind of back to gaming, back to smart contracts. If you have a smart contract that wants to power an esports tournament where this weekend, if I win the game, I get paid an incentive on chain, how do the gaming servers that power, let's say Call of Duty, for example, where Call of Duty has gaming servers distributed all over the globe, how do those servers tell a smart contract who won? How do we enable a smart contract to pay a certain wallet on chain for winning an esports tournament? Space and Time sits between these smart contracts and these gaming servers deployed all over the world and ensure that in a cryptographically guaranteed, tamper-proof, trustless way, that these gaming servers can aggregate the end game events and write them to smart contracts. Space and Time connects these gaming servers to a smart contract, so then fans, for example, could stake on an esports team. I could stake on, I don't know, FaZe Clan and say, I bet FaZe Clan's gonna win this tournament, and then I get paid along with them. Those are new business logic for gaming that we can enable on-chain if we could connect the gaming servers to a smart contract. How do we do that? Well, like I mentioned, Proof of SQL is a novel cryptographic proof. It's a ZK snark specifically for a database. This is new technology we built from the ground up. This is hard work. This requires a lot of compute, a big GPU cluster deployed all around the globe, and it requires a lot of storage, and it requires the ability for us to prove the work we're doing, prove that these gaming servers are giving us accurate information, prove that FaZe Clan actually won that gaming tournament, and connect that data to a smart contract for additional predetermined business logic to occur. Let's talk about DeFi. right now, we're in a very kind of, monolithic DeFi state. DeFi is growing and evolving, and it's growing and evolving at a rapid pace, but man, is it tough. To actually fork Uniswap and build your own DeFi protocol is a lot of work, and new financial instruments are just beginning to bud on chain. If you wanted to build a derivatives platform, like European settled derivatives on chain, how are you going to calculate the implied volatility of your options? And then therefore, how are you going to calculate your options prices? Today, think back to that COBOL mainframe 1980s picture. A smart contract does not have the compute power. It does not have the gas to calculate the implied volatility of a derivative. So right now, there are no real derivatives exchanges on chain. There's perps, which are an intermediate to get there. It's a step towards that direction. So today, a lot of these financial instruments are being built off-chain, and they're trying to connect the off-chain computation back to smart contracts. Space and time enables that to happen in a truly decentralized, truly cryptographically guaranteed, and trustless way. Now, we can usher in the next generation of smart contracts that are powerful enough to enable entire industries. I mean, imagine energy and solar on chain. Imagine mature social networks on chain, where if I post content that gets 1 million views, I get paid $5,000 of ETH no matter what, or USDC. A cryptographic guarantee that the content I put out to the social network will pay me on chain, removing advertisers and maybe removing Elon Musk. I don't know. Maybe we don't want to remove him. We'll see. That TBD. But my point is, right now, we can't build a social network on chain. We're trying. There's plenty of startups doing it, but a smart contract is not powering that business. It's mostly being built off chain. The next generation of smart contracts is data equipped. It's using the business logic of the world running on data warehouses, which are built for this purpose. Purpose-built for cryptographic guarantees of large data volumes and complex business logic connected directly to a smart contract. I'm going to get boring for just 1 second for the nerds like me in the room. The way we do that is we have a 2-layer network of validators that validate query results and validate data coming in via BFT consensus. And we have a second layer of hundreds of decentralized compute clusters all over the world that enable this. The compute clusters store the petabytes of data needed to enable these industries, and the validators ensure that the query results coming back from those clusters are accurate, verifiable, cryptographically guaranteed, and act as an oracle network to solve the oracle problem and talk to smart contracts. Okay, cool. So that's the current state of smart contracts, the near future, meaning the next year or two. What about beyond that? What about the deep future, Scott? Where do you see smart contracts going over the next 2 to 5 years? Well, first of all, ZK proofs are going to power everything. Mark my words, 2023 is the year of cryptographically verifiable compute, snarks and starks. You're going to hear the word ZK snark way more than you've ever been comfortable with, and unfortunately, that's a good thing. Interchain composability. There's not going to be one chain that wins, right? So Ethereum is fully decentralized. It has tens of thousands of network participants guaranteeing the sovereignty of the smart contracts running on Ethereum at the expense of what? Gas. Very expensive, very limited compute, very limited storage, but sovereign. Then there's newer chains like, let's say Solana, for example, or Sui, that maybe sacrifice a little bit of decentralization for better performance, lower gas fees, quicker transaction finality, more compute, and more complex smart contracts. Space and time sits in the middle to give Ethereum the compute and performance and storage that it needs to actually act like Sui, and space and time sits next to Sui to help it decentralize. Interchain composability will be everything. As I said, verifiable compute will be extended to business logic, not just ZK snarks for doing things like proving that my Twitter is really what I say it is, or ZK snarks that prove that I've rolled up 10,000 transactions from a side chain to Ethereum, but I'm talking about ZK snarks to maybe power a CRM or power an ERP system or power, I don't know, a subway system. Imagine that. All compute will be GPU accelerated. There's one thing I've learned from NVIDIA, is that GPUs are never going away. We use GPUs today for the metaverse. Think about Unreal Engine and Unity. We use GPUs for ZK snarks. ZK snark proof generation is all GPU accelerated. And hell, we even use GPU acceleration for actually processing queries. connecting business logic directly to smart contracts. Finally, we all know about the coming age of generative AI. Well, guess what? That's also going to be on-chain and also powered by GPUs. Build with space and time. If you are thinking, okay, well, maybe smart contracts are the business logic of the future, the sovereign, guaranteed participation of two parties, code that guarantees that this business logic will get executed and cannot be shut down by a cloud provider, by a government, or by an individual, then you want to start building some new applications, some new DeFi primitives, some new financial instruments on chain, and I hope some cool new social networks. Come build with space and time, because we are taking the step forward toward enabling that. Thanks.